So when we are composing functions, let's say we have f of x equals 3x plus 2, g of x equals 4x minus 5, and we want to find f of g of 4. What we would do is we would take this 4 and plug it into the g equation. So we got 4, and we've got 4 times 4 minus 5. 4 times 4 is 16, minus 5 gives us 11. Cool. Then we take that 11, since that's now the inside part, that gives us f of 11. Well, if I'm going to find f of 11, I'm not going to use this equation. I bring it down, that gives me 3 times 11 plus 2. Okay? Oh, that's an 11. 3 times 11 is 33, plus 2 gives me 35. But what if, instead of this equation having a 4, what if instead it was an x? And what if it was an x instead? Let's look at how that would change this entire problem, okay? So we have the g of x over here. Well, I can't really replace the x with an x. I mean, you can replace x with x. Let's just do it just to see what it would look like. That gives me 4 times x, it's the same thing, minus 5. Now, what did I do with this answer that I had here? I think it was like an 11. Well, I took that 11 and I plugged it into my f equation. Well, if I plug that into my f equation, I plugged the 11 in right here where the x was, okay? So that gives me, let's see here, 3 times, remember I'm not doing 3 times 11 anymore, I'm doing 3 times 4x minus 5. 4x minus 5, okay, plus 2. Well, that is f of g of x, okay? We could simplify it a little bit. We could distribute the 3. So f of g of x equals 12x minus 15. I distributed that 3 all the way through. Plus 2, I can simplify it one more step. F of g of x equals 12x minus 13. So now if I ever go through and I want to do a problem here, let's say 11, well F4 is what we had. So f of g of 4, well, instead of having to plug the 4 in here, get your answer, plug it in here, get your answer, you just take 4 and plug it right in here. 12 times 4 is 48, minus 13 gives us 35. Hey, it's the same answer. There we go. Hey guys, so let's look at this problem now. We want to find g of f of x, not for a specific number, just in general. What is the equation that we could always use to do this? Well, we've got 2 equations here. It looks like the f of x is going to go in place of x. So we're going to have our g equation, which is 5 times whatever the inside is, plus 2, okay? And we're replacing the x, so instead of writing g of x, we have f of x. So f of x, g of f of x, so 5 times f of x plus 2. What is f of x? F of x is 2x squared plus 3. So it's 5 times 2x squared plus 3 plus 2. Can I simplify it a little bit? Absolutely. Let's try simplifying it. Here we go. I'm going to distribute the 5. That gives me 10x squared plus 15 plus 2. 15 plus 2 is 17, so that gives me 10x squared plus 17. That is g of f, not g of x, g of f of x, okay? Gives us an entirely new equation. we call this a composition of functions because it's composing, it's taking both of these and compounding them into one. Composition of functions. All right, let's do these 3 problems real quick. If you think you can finish them before me, give it a try, all right? So, on this first one, we want to do f of g of x. So we've got our f equation, 3x plus 4. What do I replace the x with, though? I replace it with the g equation, which is 3x squared minus 2. Can I simplify it? Yeah, I can. Distribute the 3. That gives me 9x squared minus 6 plus 4. Combine the negative 6 and the 4 gives me 9x squared minus 2. That is my f of g of x. Okay? Let's go to the next one. We want to find g of h of x. Well, we've got our g equation. That is 3 times the inside, whatever x is, squared minus 2. We've got the red h of x, which is the square root of x plus 3. Well, let's go through and simplify. Can you take the square of a square root? Yes. The square of a square root, they end up canceling out. We're just left with 3 x plus 3. Okay, the square root and the square, they cancel. Minus 2. So we distribute, that gives me 3x plus 9 minus 2. This gives me 7, so 3x plus 7. That is g of h of x. Let's try this one. Here we go. We want to find h of f of x. Well, if we're going to find h of f of x, we take our h equation, so the square root of 3x plus 4 plus 3. Well, is there anything I really need to distribute? No, don't need to distribute anything. So it's just, what's 4 plus 3? Well, that is going to be 3x plus 7. And that is equal to the h of f of x. Okay. Now, inversely, let's say that we did it backwards. Okay. I want you to try this problem on your own. So pause the video if you need to. I want you to find what is f of h of x. Pause the video and give it a try. Do you get the same answer or do you get a different answer? All right, you should have paused the video. You should have your answer by now. I'm going to draw a line here to separate them. So our f equation is 3 times x plus 4, but we replaced our x with h, which is the square root of x plus 3. Well, we distribute, and distributing doesn't really help us too much here. It's just going to leave us with 3 square root of x plus 3 plus 4. That's about all that we can do with this problem. Are these the same? No, they are not. Is the order important? Yes, yes it is. Okay. I'll do one more example for you guys. Hey guys, so here's a new problem for you. All right, we want to find r of s of x and s of r of x. Okay? Give it a try. Pause the video if you need to. This is the last 2 examples that we're doing. All right, you should have paused it. You should have your answer by now. So let's do this first one. We've got r of s of x. So we've got our r equation. So 5, we're replacing the x. Okay? Well, if we're replacing x, we're replacing it with 9x. What is 9x squared? Well, that square is acting on the 9 and the x. It's like taking 9x and multiplying it by 9x. Well, 9 times 9 is 81. So 5 times 81 times x is x squared minus 3. 5 times 81 is 405. Okay, that is our answer there. That is when we do r of s of x. But what if we did it the opposite way? What if we got mixed up, or what if we just want to know both of them? Well, in that case, we have s of r of x. So we've got 9 times whatever x is. X in this case is 5x squared minus 3. Oh, there's no square, so we have to square it. So all I have to do is just distribute the 9. Okay? That gives me 9 times 5 is 45 x squared minus 27. Do those look the same? The only thing that's the same is that they both have a minus sign and they both have an x squared. Aside from that, there's not a lot of similarities. So, the composition of one set of functions usually, almost entirely, almost always, will not be the same as if you reverse it, okay? So, ask me a couple questions, shoot me an email if you have questions, if you're watching this after class, and you guys have a great day.